Okay, guys, today we are looking at 9.3. So we're going to start converting equations today. Previously, we converted just singular points between polar and rectangular forms, but today we'll be converting some equations. Before we get to the new stuff, let's start with a warm-up. I'll get you started here, and then I'll have you finish the warm-up on your own. So here we're going to state three other pairs of polar coordinates. So this is our point right here. Remember, polar is r theta, and it's asking for the other 3 points to still be between negative 2 pi and positive 2 pi. So basically just on the unit circle. To get us started, let's just look at plotting this point. So we'll just sketch where this point is. Polar, remember, is using circles. So first I want to figure out where negative pi over 6 is. I always start with the angle. Well, I know that positive pi over 6 is in the first quadrant. So negative pi over 6 would have to be in quadrant 4. Remember, negative and positive angles are above and below each other. So here's negative pi over 6. And then remember that a negative radius tells you to go away from the angle. So I'm actually going into quadrant 2. So that puts my point right here. Now, before I list the other 3 points, I'm just going to collect all the angles I'll need. So I have negative pi over 6 in quadrant 4. I know the normal angle there is 11 pi over 6. And then I'm going to need the 2 angles up in quadrant 2. So our regular angle here is 5 pi over 6. And our negative angle that goes with it comes from quadrant 3. In quadrant 3, it's 7 pi over 6. So pushing it up to quadrant 2 would be negative 7 pi over 6. This makes it a little easier to actually list out the coordinates. So the other 3 coordinates, there's going to be another negative 1 radius, a positive 1 radius, and a positive 1 radius. So pause the video, see if you can fill in the blanks here, and then press play to check your answers. Remember that we want each coordinate point here to end up in quadrant 2. To actually end on that angle, so you can match up your angles appropriately. Remember, negative radius goes away and positive radius goes towards that angle. Okay, so moving on to some new stuff today. We're going to continue looking at those equations that we've been working with this unit. So up here, we'll just fill in those formulas. So here's our graphic showing the connection between our polar coordinate and a rectangular coordinate. Now, just to collect all the formulas in one spot, we already know that r squared equals x squared plus y squared. That's our Pythagorean. And I can solve that for r. So r equals square root of x squared plus y squared. And then our other formulas that are helpful today, x equals r cosine of theta, y equals r sine of theta, and theta equals tangent inverse of y over x. So these are the formulas we've been using to convert between points, and we'll also use them to convert between equations. So today we're just focusing on converting from rectangular to polar. So our first example says to change x squared plus y squared equals 9 to a polar equation. That means our final answer, we need r and theta, and we want no x or y. We don't want any x's or y's left when we're done. Another fact with our polar, we know we'll be done when polar polar should be r equals whatever the equation is. So we know we're done once we solve for r. Okay, so basically we're going to do a similar process we did with converting points, but here we're looking back to the equations that we wrote up the top and seeing where we can replace our rectangular variables with a polar variable. So for example, right away I see x squared plus y squared. I look at the equations we have up top here, and I see x squared plus y squared equals r squared. Now, since they're equal to each other, I can interchange them. So this becomes r squared equals 9. But I want to solve for r, so I have to get rid of that square. I can do that by square root both sides. Remember, when you take the square root in an equation, you always have plus or minus. So r equals plus or minus 3. And I'm done. Okay, that would be our polar equation. Next example here, we're going to change y equals 3 to a polar equation. So again, we're thinking back to those. So if you have to look back at those equations again, see what you can plug in. We had y is equal to r sine theta, so I can replace that right away. Remember, I want to get rid of y's and have r's and thetas. So r sine theta equals 3. And then I'm going to solve for r. So just like regular solving equations, I can divide by sine of theta because these are being multiplied. R equals 3 divided by sine theta. Now, we don't typically leave a fraction like this, but from our identities unit, we know anything divided by sine when sine is on the bottom. We can use that reciprocal function. So it's 3 times cosecant of theta. Because remember from the last unit, sine equals 1 over cosecant. Whoops. Okay, and we got 2 more here. Example 3, similar to the first one we did. So we have x squared plus y squared. I know that's the same as r squared. And then I have this variable x I want to get rid of. That's the same as r sine theta. So we're just substituting in with the equations from the beginning. Now again, I have to solve for r. I notice I have an r, at least one r on both sides. So I can divide by r on both sides. These cancel out. One of these cancels with the denominator, leaving me with r equals 4 sine of theta. There's no fraction here, so I don't have to do any reciprocal work, so I am done. And our last one is a little bit more complicated. So we are starting with a linear equation. So rectangular equations for us will always be circles or lines. So this is an example, number 3 of a circle equation, x squared plus y squared. This is a linear equation. So I'm just going to replace x and y with what I know it's equal to. So 5 times r cosine theta for x plus 7 times r sine theta for y equals 12. So now I've gotten rid of x's and y's, but now I still need to solve for r. So I notice I have 2 separate terms because of the addition. I have an r in each term. That means I can factor out r to kind of get it alone. So I factor out r, bring it to the front, parentheses. Now I'm just left with 5 cosine theta plus 7 sine theta equals 12. If I want to get r by itself, remember this is multiplication here, so I can just divide each side by 5 cosine theta plus 7 sine theta, leaving me with a final equation of r equals 12 over 5 cosine theta plus 7 sine theta. It looks ugly, but r is by itself, so I'm done. For this fraction, we're okay leaving it because it's a little bit more complicated to get rid of the fraction, so that's fine. It just